Okay.
Do you see our face, Massimo?
Yes.
Okay.
Okay.
No.
Okay. Company.
Okay, the company. So a few words. Let's try to give some details shortly. We produce intrinsically safe and seal certified devices for main application in oil and gas, chemical, petrochemical, and the pharmaceutical, all application where EX devices are installed, and also where the seal is very important. We have a very long experience, more than 40 years, even if Germany itself has been founded in 1993, but the company and the experience comes from a previous company. We have a complete production in Europe, in Italy, Milan, but also we have a presence in all 5 continents, some 10 offices in different parts of the continents, different distributors. Of course, we work with local distributors, and also we have a little bit more than 200 people. We also organize this kind of events like webinars, so functional safety courses, OEX courses, cybersecurity courses, different courses. If you have any question just about that, because this is a specific department of our company, you can say, ask to us. About the production, we have complete traceability, full testing, 5 years warranty, and also 10 years warranty availability for all products. About certification, all certification available for different application areas in the market and also in different parts of the world. So we have certification for Europe, for Americas, for India, for Brazil, for China, Japan, and also we certified our design, so the systematic capability is free. So our product is seal free, are also, let's say, supported by the design, which is certified seal systematic capability 3. This is a product. We produce intrinsically safe barriers, safety relays, which is the part of today, and isolators for seal applications, seal power supplies, multiplexer, termination board for all DCS and PLC applications, hard multiplexers, surge protection, indicator, and also, as I said, the courses. And about our customers, we work with the different system vendors, EPC, OEMs, and users. The presentation is divided by chapter. So this is all the chapter. So we start from safety and the smart relay concept. I don't know which number, maybe it's yours or it's still mine. Okay. It's mine.
Mine.
Okay. Okay. Please.
Okay. Thank you, Andrea. And let's start examining those that are a fundamental part of a system. Let's talk about safety relay. A safety relay can stop or initiate a movement in a controlled or safe manner by opening, closing valves, start-stop motors, and so on. And they must conform and adhere to the ESD 61 and 5000 and the industrial standard. Not only in oil and gas or process industry, but in general, a safety relay can be used where a failure of a relay can cause serious accident to human or environment or asset or image. So, but what are the typical cases where a safety relay is required? Well, typically we must use a safety relay in all those applications where the controller, our PLC, digital output card of a PLC, for example, is enabled to activate a field device due to its limited potential in relation to the voltage and current involved, or in those applications where multiple contacts for the simultaneous activation of multiple load is required, or again, in those applications where the safety function that the controller must perform needs to be inverted. But what is different from a standard to safety relay, and why a standard relay cannot be used in a SIF? I leave Andrea to explain this point.
Yes, of course, there are many things why standard relays cannot be used in a SIF, but you need to use a safety relay. So a SIF relay is a device with no warranty availability to perform a given safety function. So the product itself is, of course, has a lot of different components inside, and the components have different failure rates, and the failure rates, of course, are calculated in FMEDA, and total FMEDA give a certain sale rating for the products. So this is, of course, really could differentiate the safety relay from the standard relay, which has not, of course, the FMEDA. What can the relay do? Of course, the goal, the target is reach a safe state on demand. So most applications are really simple. So you have just open or close or start, stop something, motor or valve, and as in this case, or activate the fire extinguisher. So it's very, most of the time, in this case, of course, are low demand products. Most of the time they remain in, say, in a normal position, and when needed, has to, of course, open or close the circuits. Typically, for ESD, IPS, BMS safety function, the load is normally energized, and in case of failure, you need to de-energize. So the safety function is DTS, de-energize to safety, meaning open the circuit. But the other way around, you can have in firing gas normally de-energize loads, and in case of safety, you need to energize the circuit. You can see here a simple circuit where you have, of course, 3 relays series that are used for non-energized load, where you have 3 relays in parallel in the bottom, say, in the drawing there, 3 relays in parallel that are used for energized to safety applications. That is basically so the circuit, and most of the time you have exactly this kind of loads to control. Massimo?
Okay, well, before going into the specific of how a smart relay works, let's see what a smart relay is. The smart relay is a device that guarantees a specific safety function, like a typically safety relay, but in addition to the safety relay, it has the ability to perform a complete field diagnostic. For complete diagnostic, we mean a diagnostic that includes complete constantly monitor of line and load functions in both operating condition of the relay, on and off status. In fact, the diagnostic of a smart relay is able to monitor the functional parameter of the field device and the line, to know in real time the health status of the loop in the condition of load energization, and as a predictive function to know whether in the event of a request for intervention, the device in the field will activate correctly. This is very important, especially in fire and gas safety system. We can say that smart relay combine the basic functionality of the safety relay with a complete line and load diagnostic. But why going for a smart relay? Nowadays, full diagnostic is typically required along the full loop. And however, many widespread systems do not support diagnostic inside their digital output cards. Smart relay make diagnostic available to systems that do not support it. In other case, many modern systems do not support digital output diagnostic. However, in many applications, they cannot directly drive the load because they are voltage and current limited, typically no more than 500 milliamp at 24 volt DC. Or again, when the load, valve, beacon, sounder, etc., require more than 24 volt and or more than 500 milliamp, relay in this case are necessary. Yet when using standard relay, the digital output diagnostic dies at the relay coil and cannot reach the load in the field. As opposite to that, a smart relay can go beyond the typical voltage current system limitation while keeping the full load diagnostics. Even if modern systems can perform load diagnostic, their capability may be limited. For instance, early leakage monitor may not be supported, or extreme load, for example, beacon, may always be reported as an open circuit to the system. Smart relay may offer a solution to extend the digital output diagnostic capability. We can say that two different safety functions coexist inside a smart relay. The first and also the main function consists in the input to output or coil to contact activation, deactivation. This is the typical function of a safety relay, which upon request is able to drive a load applied to it in a safe state. The second one is the diagnostic function. It provides full measures, voltage, current, resistance, or in case of specific model of smart relay, air leakage of the load, also through Modbus protocol, and it can activate, deactivate to fault dry contacts. The smart relay is equipped with 4 relay, and any anomalies can be acquired through the Modbus protocol. Also, the smart relay is available for installation in hazardous areas, to be precise in Zone 2 or Division 2. We can also say that the main function, coil to contact, is certified seal-free, while the diagnostic is certified seal-2. Well, Andrea, I think we have a poll for our attendee, the first poll.
Yeah. We want to ask you if you can answer to this poll. So just to know what kind of relays you are using on your application, if you are already using or not. If you are using common relays or if you use standard relays, safety, of course, is the biggest part. Is also you use safety relays with diagnostic like this one, or maybe, of course, the PLC. That there are a lot of PLC that integrate the some, not all, but the relay functionalities. So some PLC, some cards, in this case, digital out cards integrates the diagnostic for some parameters, of course. What kind of type do you use if you use, of course, some safety relays or not? Okay, thank you for answering. We try to close as soon as possible. Maybe I still see some answer from your side. Thank you. This is very important also for us. So for our future development, we need to know what our customers and our people are using. So I see that most of you use standard safety relays. We can close it right now. Thank you. I want to just share with you. So this part, you can see that most of you use standard safety relays, but quite nice part related with diagnostic functionalities. And as I said, few of you also use PLC with integrated relay functionality, which is also very important. Okay, thank you. We can go on. So this is mine. Okay, what GMI did, we use, let's say, special relay metrics. You can see it there, and it's very, let's say, unique architecture of relays where we have metrics of relays. So you see the load that is driven by 2 relays in parallel and other 2 relays in parallel. So there are 4 relays working simultaneously. When you activate your DO from your system, all of them, of course, move simultaneously. We have, of course, by our calculation, we have seen that it's a very good solution for universal, for non-energized and normally de-energized load. So we use this matrix now on all new relays we are doing. So it is very important because in seal calculation, safety is very important, but what is not calculating seal is the availability, is of course the possibility of maintaining the system running without any fault. What does it mean? It means that if you have a fault inside on your availability is low, of course, maybe you can stop your plant because for maybe a failure of your system, not a real, let's say, safety problem on your plants. Just a failure on the hardware can stop the plant, and you can have some trouble because let's say the system is not running, is not producing, and the owner, of course, is not happy about that. We have seen that is one relay, if you see there, is supported. The failure one relay is supported. So hardware fault tolerance in this case equal to 1. So I can have one failure, but in this case I have to open the circuit, and one relay is stuck. The circuit remains open because there are the 2 relays on this part that let me highlight it. This part are opening the circuit. But the other way around, if you want to close, one is not closing, the circuit, of course, if this one, if you can imagine the other way around where you are closing, this is not closing, this relay, the circuit will remain closed because you have this line closed. So in this case, you have a possibility where you have a seal tree safety function. In this case, a relay fault is not sufficient to create a dangerous condition. And also, you have high availability. So a relay fault is not sufficient to activate a spooling strip of the load. So also in case you don't have any safety necessity on your plant, the relay fault is not, of course, affecting your systems. Hope this is clear. We can, if you have any questions, just, of course, write on the Q&R button to the Q&R questions. Okay. What the other feature we have is a pass testing. So basically, all PLCs, or most of all PLCs, have the pass testing on the DO card. It means that on the system, the PLC is testing continuously the DO for verifying that the system is working, the load is correctly. So there is this kind of diagnostic. Of course, in this case, you need a safety relay because maybe your load requires more power because you want to extend the diagnostic because you want to change the safety function. There are a lot of reasons why you are using a relay. And when you use a relay, of course, there is an isolation between input and output. And of course, the pass testing is no longer valid, is no longer working because you are not testing the load. But sometimes you could have the system or the relay can be affected by that because if you have this pass testing, meaning that the load is flickering because you are activating continuously with this pass, can be positive or negative, can be closing or opening, of course, depending on the function. But our relays, of course, are compatible. So there is a circuit that is filtering completely the path testing. So the relay is not, of course, affected by this kind of chattering. Okay, so let's go to the next one. Massimo, is yours, I guess.
Okay, let's see now specifically how the relay can communicate with the system. Smart relay can report the field status to the system in several ways. For example, the two-fold contact can be acquired by a system digital input card. This is the typical way, which implies the use of DCS with a dedicated digital input card, where the status of a contact called a fault is monitored by the system. The second method, if the system digital output card driving the smart relay support pulse testing, the fault in the field can even be mirrored directly to the digital output card without the need of any additional digital input card. Or again, a complete diagnostic information can be retrieved through Modbus multi-drop RS485 protocol if Modbus master is available on the system side. Through the Modbus protocol is also possible constantly monitoring and configure the smart relay. Or again, the fault on bus can also be acquired by a system digital input card. The fault on bus is normally used when a cumulative report is required.
Okay, thank you. See that there are a lot of functionality for safety relays. And of course, we have few, I'd say, information to give. So, of course, the relay are C3 tube certified. Can be used the 5096S, 5096S-100 B5294S for fire and gas application, non-energized with high availability, because all of them have this matrix of relays inside, as from the previous slides. The 5097S, 5295S are mainly used for fire and gas application with phase inversion. What kind of diagnostic? You can have monitoring the current on load, voltage, current on load, the load resistance, this is a pattern, the leakage from load to earth, the coil integrity, internal fault, and of course with the Modbus RTU available on a few of them, not all of them. If you remember, of course, the coil integrity, meaning that the single fault, the single relay fault can be monitored. So if I have one fault inside, I can get this information. Of course, the system is still running, is working properly, but I know that my relay is having a fault. I know that I have to maintain or repair or replace the device. We see that we have two relays, alarm, okay, two possibilities, on the bus via Modbus. We have, of course, tested with different PLCs for having the, of course, they're compatible with the line bus testing, but the very important thing is the fault mirroring on the OCR, meaning that the systems can get immediately by impedance variation on the DO the fault. This is very important because you don't need to use external digital input for acquiring the fault. You can directly read them through your DO. Contact rating 4 amps with the 6 amp rush current, installation for zone 2, div 2, universal mounting, the array, power bus or termination boards, and of course there is complete isolation between input, output, and power supply circuits. just this table give you more details what kind of fault you can acquire. So if you want to have a complete diagnostic functionality, last two, of course, are the most important because they grant the full diagnostic. The first two, of course, they are limited. So the internal co-integrity is only for the, as I said, for the single relay fault are available on the last two. We want to just remind you that you will get a certification, attend a certification, if you, of course, participate at least 70% of this webinar. So I know I tell you that this because some of you asked this. So we will provide you a certification, of course, if you attend most of the time. Okay, Massimo, it's your turn now. Now we go to the dedicated fire and gas application. So you will see how to use our system.
Okay, Andrea, thank you. And let's introduce the specific topic of today. Typically in today's process industry, there are different types of application. Of course, one of the most important is certainly the fire and gas system. But what is a fire and gas system and what are the tools that GMI offers to meet the needs of this type of application? Well, a fire and gas system, safety system, continuously monitors for abnormal situations such as fire or combustible or toxic gas released within the plant, and provides yearly warning and mitigation action to prevent escalation of the incident and protect the process or environment. In most cases, a fire and gas system involves the activation of a load, such as a deluge valve, alarm signal tools such as bells, sounders, or beacon, or ventilation system, and so on. Of course, the brain of the controller of the system is the safety PLC. But to make a plant or the entire industrial process safe, it must use intelligent tools such as smart relays. Because they are called smart relay, because this relay allows to the PLC to extend its diagnostic capability up to the final load, which in the fire and gas system is that element that is activated to protect the system or to give the alarm signal. And why it's important in a fire and gas system to always be in control and always know what is the state of the system? Well, the answer is what will happen if at the beginning of a fire, the fire and gas system is not available due to its own failure to intervene to mitigate the damage. We would have disastrous consequences. But let's see how a smart relay can help us and how it works in a fire and gas application. First of all, we can say that internally, a GMI smart relay is composed of a matrix of a contents, which allow us to have high reliability and high availability to the process. This safety relay is in fact SIL-free certified for both for application with normally de-energized load, our fire and gas system, and for application with normally energized load, for example, ESD application. But let's see it specifically. The load applied to the relay, in this case a beacon, is off in normal condition and the relay contacts are open. When at the request of the safety PLC, the load must intervene to signal the dangerous event, the relay closes its contact, through them it supplies power to the beacon, which gives the alarm signal. A typical fire and gas application involving GMI's D5294S smart relay is the following. The D5294S monitors the line, the power supply, and the load, in this case a sounder in our slide, under normal condition when the loop is switched off. By doing so, it ensures that if requested by the PLC, the loop will work correctly. This type of relay can be configured via software or via Modbus for specific diagnostic value. When switched off, it's able to monitor the impedance of the load, the power supply to the load, and is able to auto-check the coil of its internal electromechanical relays. It's also able to provide true-fault contacts towards a DCS system dedicated to the purpose, or it has the possibility of mirroring any fault detected in the field directly on the diagnostic PLC card. This function called fault mirroring is compatible with different types of digital output cards of the most common PLC system and allows considerable saving in terms of engineering cost, as it allows the non-use of a DCS system dedicated to the acquisition of a fault. Let's see how it works. The relay monitors the loop, and if it detects a malfunction of the load or its power supply, it immediately reports it to the PLC through the mirroring function or to a dedicated DCS system by closing two fault contacts. This is called predictive diagnostic, fundamental in fire and gas system, to ensure that the loop will work when there is a real need. The smart relay, in this case, through its diagnostic function, allows the PLC system to extend its loop monitor capability up to the load. For this reason, and many others, the smart relay is a fundamental tool in a fire and gas loop. Furthermore, this type of relay can communicate and can be programmed via Modbus with all the advantages that this communication protocol can give. In the next slide, we introduce what is the relay programming software, which allows us to have total control over the functional parameters of the load and the voltage applied to it. As previously said, in condition of relay off, it can monitor the impedance of the load, the power supply voltage of the latter, and the health of the internal electromechanical relays. This relay it also allows us to set windows of values within which the diagnosed variables must fall in order not to generate a fault. In fact, for example, we can set a minimum and maximum value for the load power supply, outside of which the relay will signal an anomaly to the system. The typical example may be that represented by the short circuit on our load caused by a malfunction of the winding inside the beacon, for example. The relay, by monitoring the impedance of the beacon input circuit, will read an anomalous value outside the window of value considered valid during relay programming, and will signal a fault to the system. This fault signal will occur through the closure of two fault contacts to be acquired through a dedicated DCS system, and a red LED will light up on the front of the relay. Through the programming software, it's also possible to monitor in real time what happened in the loop. Any fault will be underlined by a red indication and will warn us that the monitor value have gone out of normal operation activity. The D5294S is also able to monitor any leakage between the load and the her. This particular feature is part of the predictive diagnostic perspective for a fire and gas system. This data provides us with particular information on the health of the load, informing us if a possible air leakage can be harmful to our application. Also, in this case, the configuration software provides us with important information on the state of health of the load, monitoring the impedance value that the load has towards the ground. In case of fault detected, the relay can communicate the fault occurred to the system to allow us to act promptly on the problem and solve it. Now see another model of smart relay. Some old PLC systems work with inverted logic and always supply energization to the relay. For this reason, we need a relay that reverses the safety function of the SYS to bring our fire and gas system to safety. Also in this case, GMI Smart Relay help us by giving complete diagnostic coverage to the loop and helping the PLC to reverse the safety function. In this case, the D5295S model maintains the function of the model present previously and changed, but gives us the possibility of inverting the safety function using normally closed contacts. In fact, under normal operating conditions, the load will be normally energized. Therefore, for a fire and gas load, the PLC system must have a normally energized logic so that the relay can reverse the function on the load. In this way, the relay contact will be open during normal loop activity. At the request of the PLC, the relay will be de-energized and the contact will close energized load, which will provide the alarm signal. Also, for this type of relay, thanks to the contact method technique, we will obtain high process availability and high level of safety seal-free certified. Also for this smart relay, the diagnostic function remains unchanged. In fact, with a view to predictive diagnostic, we will be able to monitor the state of the load and its supply voltage when the relay is energized, that is when its contacts are open and consequently the load de-energized. In this way, we will be able to monitor the impedance value of the load to verify its state of health over time. In case of anomalous variation of the load input circuit, the relay will signal the change to the safety system, declaring a fault. For which, as we have seen previously, can be signaled in different ways through the mirroring function, through the fault contacts to be dedicated to a specific acquisition system, or even we see now the ESD application. The types of relay, the next slide, Andrea. Okay. The types of relays seen up to 9 for fire and gas application are also widely used for emergency shutdown application. In fact, thanks to the contact metrics, these relays are able to perform a certified seal-free safety level and high process reliability even for this type of application. But how does a relay work in an emergency shutdown application? Well, the relay in this case is that device which, at the request of safety PLC, must ensure the de-energization of its load and bring it to a safe state. Typically, we are talking about a shutdown valve, which must interrupt the flow of dangerous fluid to bring the system to safety. In this case, we are talking about an application that involves a typically energized relay, which in turn works in normal condition with its contact closed and energize the shutdown valve, which in turn allows the passage of dangerous fluid. Also in this case, the use of a smart relay is important to monitor the health of the valve. It's necessary to know in advance any problem that could arise in the event of a request from the safety system if the valve should have any problem. The smart relay guarantees complete diagnostic of the load and of the line associated with it, even in the condition of the energized relay. In this condition, the smart relay constantly monitors the power supply voltage of the valve and the current that circulates in the coil of the latter. In this way, it's possible to monitor every slightest variation in the state of the relay load loop. And also in this case, the smart relay helps and extends the diagnostic capability of the safety system. As previously mentioned, even for normally energized load, thanks to the contact matrix, the D5294S smart relay provides high availability to the process. In fact, the failure of one of the contacts inside the matrix is not sufficient to generate a malfunction of the relay, which maintains its function and changes also for this eventuality. Even for this type of application, the configuration software signals any load malfunction by reading the variables related to the load itself. The signaling takes place on the monitor, underlying the cause of the fault in red, or with the types of communication seen previously. Another particular application involving smart relay with normally energized load is that related to valve with dual coil, for example. In this specific case, since each coil is sufficient to activate the valve, the two coils avoid false intervention in the event of a single coil opening, thus increasing availability. In this context, the D5294S can detect the opening of the single valve coil. Through the configuration software and by specifically setting the diagnostic value of the current flow in the two coils, it's possible for the smart relay to detect if one of the two coils is interrupted. In fact, if one of the two coils is interrupted, the current circulating in the loop is halved and the value read by the relay leaves the window of the set values, signaling a fault. Fault that also in this case can be signaled to the safety system in different ways. One of these is the mirroring of the fault, which communicates the problem with the load directly to the digital output card of the safety system. Through this, signaling towards the safety system is through a variation in the impedance of the input circuit of the smart relay. This functionality has been tested with some of the most popular safety PLC on the market and found to be fully compatible. Well, Andrea, I leave you for some words on Modbus and compatibility with our devices.
Thank you, Massimo. Hope you are still there. I think you are alive. I see you. Maybe we have another poll. If you want to say what we want to ask you, what kind of safety relay features or smart relay features you consider as relevant. So if it's the compatibility with the past testing, we have seen that is very important if you when it's connected to a PLC that is generating these pulses for controlling, or the fault out, or the fault mirroring on your DO that prevent from using additional digital input card for fault acquisition, or the Modbus output. Also the threshold, configurable threshold, because sometimes we've seen a massive experience, a lot of that application where we have some fault, some loads that if you're using normal relays, you get in fault immediately without any alert, because of course the impedance is very high, and if you use the standard relays, it detects immediately a fault. So in this case, you need a specific, you need to set the threshold in order to do not get a false fault. Okay, thank you. I see that people are still answering. These are also, let's say, of course, important for, let's say, stop a little bit the flow of the slides, and also for your attention. Thank you. We can stop right now. Thank you. And we can go ahead with the next part. So, Modbus interface. So, some of our relays offering the Modbus interface. In this case, can be very important, because if your PLC support a Modbus communication through a Modbus port, a Modbus master port, could acquire different relays in simple two-wire. By daisy chain connection, you can connect up to 127 modules in one single Modbus port. Why is important? Because in a Modbus communication, let's say that in the standard communication, you know that there is a fault, and the fault, but you don't know which kind of fault. That's important. So you know the fault because you can acquire through the mirroring functionality by the fault contact. You know that there is a fault, but you know if there is a short, open power supply, or earth leakage, whatever, you cannot distinguish the type of fault. Why? By a Modbus, we have different registers, and each fault is associated with a different register. You know exactly the type of fault that you can get. So you have one Modbus interface for all relays connected. Communication up to 1200 meters. You don't need this K digital input for alarm monitoring, because everything is through Modbus. And as I said, of course, information is clear about the type of fault, because there are specific registers on that. Okay, so we came to the conclusion, and we want, of course, give you more details. So we have used our relays with all systems, applied, of course, for safety applications, because the topic today is safety. And of course, Schneider and Yokogawa have different, they have also DCS, of course, and they have different safety systems that in this case for Schneider can be the Tricon CX, can be the Modicon, M5 and 80S. Or for safety, you have Yokogawa ProSafe or Honeywell Rusio, the new safety manager. So they have a different, so we have tested with different systems. You see that basically is working with all of them. With some of them, for some of them we have a test report, for the others not, but we, based on our very long experience in this market, we have tested with all, also with Rockwell or with EMA or the ABB. Okay, Massimo, we can just give you the short information to conclude our webinar. So, important features. Massimo, go ahead.
We try to summarize what we are discussing in today's presentation and why it's important for our attendees. A universal solution that our devices, and in particular our smart relay offers, which allow us to extend the limits of the system digital output card for the compatibility of all the loads applied to it and in all conditions.
So we have seen that major and very important diagnostic lever. So all faults can be acquired. We can repeat once again, open and the short circuit, the power supply fault, the ground leakage, the load resistance variation, and the relay failure or coil failure, as we call it in our slides.
Another important feature is the contract metrics inside to our smart relay that offer high process availability and full tolerance for the prevention of spurious trips with the contact metric GMI smart relay, which allow more resilient solution that prevent the system from downtime.
So we have a CL3 certification with a very long lifetime of 20 years. Of course, a CL3 relay can be used also in CL2 applications. The only difference in CL2 application, you have, of course, the typical full time, which is longer than CL3, but you can use also in the CL2 applications.
And the most important feature that our smart relay have to communicate the fault detected in the field towards the safety system is the transparency of the field fault through the mirroring functionality of our smart relay, allow significant saving in terms of installation and wiring.
So you don't need, this is the advantage, you don't need to use the advantage of mirroring. You need to use additional DI cards. You reduce the hardware, wiring, and simplify the engineering.
And the great flexibility with GMI solution, which allow you to manage all types of loads and field condition in small spaces.
So we have a Modbus interface, which is not common, but we see that is very well used more and more. So prevent for any, let's say, problem troubleshooting, you don't need, of course, to open and looking at what happened because you already know in your system that specific type of fault.
Okay, and the possibility with our smart relay to manage types of loads connected both in unipolar and bipolar way, guaranteeing field diagnostic where required. This solution allows great saving in terms of installation cost.
Interoperability testing, we have a lot of application notes based on that and the test with different manufacturers that can, let's say, of course, be of your help if you need any specific things. Okay, we finished. We want to just remind you that
we have a question from our attendee.
Okay, yes.
Related to the lifetime and how it's tied to the perfect test interval.
What can you answer to that?
But the lifetime is typically our device, especially for the safety relay, is 20 years.
Yes.
And to maintain this specification is necessary to perform the proof test described in safety manual that we have on.
Yeah, of course. But really the question was how could we have the proof test to 20 years? That's very impossible. Very impossible because a device that can stand for 20 years needs some test to keep at least at the cell level. We have relays that the test proof is about 8 years. So every 8 years, if you want to keep the seal-free level, you have to retest again, and based on what we say in our manuals. But 20 years is very difficult. We can't of course have this kind of say would be T-proof-less, of course, device is very, very difficult to have it. Okay, he's asking, is every 4 years enough for a test? Yeah, I would say yes, depending on the relays, because every single relays have a different T-proof, depending on the hardware, and this is, I cannot say yes for all, but at least for major our products, 4 years is enough for a test, even more.
But it depends also from the condition of works of the relay, the application, the specification of the application, etc.
Exactly. Okay, so I like webinars. We have a complete program you can see on our website. You can see also this webinar recorded on our YouTube channel and others. So you can, of course, share with your colleagues if you need it. Just the last, of course, how did we do? If you like it or not, please be, let's say, not polite, I would say, say what you like. Of course, this is anonymous, you don't write your name, but this is very helpful for us in order to improve our communication. And of course, we try to do our best, but that is not that also, let's say, always possible. Thank you for answering. And we remind you that, of course, we have other webinars for other topics, like cell aspect and normative, EX aspect, and cybersecurity. So let's say, please stay tuned on our program, and thank you for answering. We close it. No, we don't share it. No. But your answer was good. Thank you very much. We remind you just our name, our emails, and our face, of course, if you like. And if you want to write us anything and have any more further information, let us know. Thank you very much to all of you, and thank you, Massimo.
Thank you, Andrea, and thank you to all our attendees for their attention.
Thank you. Bye-bye.
Thank you. Bye-bye.